Welcome to Study Loop.
So now we're going to work on problem 82 from chapter 17. Here we're given three compounds, and we're asked to pick an indicator which we would use for these, to use in a titration with a strong acid for these chemicals. So what we need to do for the weak bases here is we need to calculate the pKa's of the conjugate acid, because the pKa can be related to the pH, which is how the indicators are reported in table 17.1. So the Kb for methylamine is 4.4 times 10 to the minus 4. Now we know that we can convert this to Ka by dividing 1 times 10 to the minus 14 by Kb. And so Ka is equal to 2.27 times 10 to the minus 11. And pKa is just the negative log of that value. So pKa is equal to 10.64. Now we can look at table 17.1, and we can look at the values for the indicators, and we see what we are looking for is we want a indicator that will have a color change within plus or minus 1 pH unit of the pKa. So we're looking for a color change from pH 9.64 to pH 11.64. And so what we see here is that alizarin yellow R is the best choice because of this color change. Okay, so we can go ahead and look at problem B. So for NaOH. So for NaOH, we don't need to calculate the pH because we know that when we're titrating a strong acid with a strong base, the neutralization will occur at pH 7. So we can write down that the equivalence point will occur at 7. So we look at the table to see what has a good color change from pHs 6 to 8. And we can see that there is a indicator called bromthymol blue, which would be good in this case. And the last chemical that they give us is aniline, aminobenzene. So we see that the Kb for aniline is equal to 3.9 times 10 to the minus 9. And from that, we can calculate the Ka of the conjugate acid as being equal to 2.56 times 10 to the minus 6. And from there, the pKa as being 5.59. So we're looking for a difference in pH equals to 5.59 plus or minus 1. And when we see the table, the best indicator for that purpose is methyl red.